Hello everyone, Mr. Fawcett here, and we are back for part 2 of our lesson on the chain rule. Today's video is going to be strictly examples. We're just going to go over some different types of problems you may need to apply the chain rule to, as well as our previous derivative rules. So again, calculus is cumulative. We're rarely looking at something strictly in isolation, and we have to be able to pull from units in the past. We have to continue to use those tools in our toolbox that we learned previously and not just the one we're currently on. So we're going to do some chain rule, but we're also going to do some power rules, some quotient rules, some product rule, etc. We're going to start with problem 7. So it says, now that we know the 3 big rules of differentiation, the product, quotient, chain, we also have the power rule back in there from our previous unit. We're going to now see how we can use them in conjunction with one another. So again, we're going to do problem 7. I encourage you to pause the video, try it on your own, see what rules are required here to do that correctly, and then we are going to go over it. Okay, so first off, we notice that we have a product here. So we have 5x times the square root of x plus 3. So we're going to have to use a product rule, but we're also going to have to use the chain rule. So we're going to have to use the product rule because we have a product, and we're going to have to use the chain rule for the derivative of this factor, right? We're going to have to, derivative of 5x is quite straightforward. The derivative of the square root of x plus 3 is a little bit more difficult, and we must use the chain rule. So let's dive right in. All right, so, oops. Let me get my pen out. There we go. So f prime of x. You can label these two functions if you wanted to. It may be helpful for you to do that. Let's call this one g of x. Let's call the other one, call that h of x. So the product rule would say, now I need to move this down. Okay, product rule would say that f prime of x is equal to g prime of x times h of x plus g of x times h prime of x. Again, the only difficult thing to find here is h prime of x, because that's going to be our chain rule portion. Let's do the other parts first, though. So that means f prime of x is going to be equal to g prime, which is 5, times h of x, so 5 times the square root of x plus 3, plus g of x, which is 5x, plus the derivative of h. So we need to find h prime. So let's come over here. Let's come over to this other side for me. So I got h of x is equal to the square root of x plus 3. Again, you can just treat this as its own problem and then insert it into our problem over here. So I'm going to rewrite this with an exponent. And we are going to go through the chain rule process. So h prime of x is equal to the derivative of the outside. So I get 1/2 times the quantity x plus 3 to the power of negative 1/2 times the derivative of the inside function. My inside function is just my x plus 3. The derivative of that is just 1. So h prime of x is equal to 1/2 times the quantity x plus 3 to the power of negative 1/2. And then if I simplify that, I'm going to get 1 over 2 times the square root of x plus 3. Now, I definitely didn't show you every step there. If you are confused on how to take the derivative of h of x, you can go back to video 1 where we did several examples going more in depth in how to use the chain rule. But this is the, again, once you become proficient at the chain rule, this is the process I expect you to take. You won't have to go through and write out all those extra steps with our c's and whatnot. Once I have this, I'm going to come over here substitute it in for my h prime of x, and then I just have to simplify. So let's get rid of this so we're not confused. Do a new color. So f prime of x is equal to 5 times the square root of x plus 3 plus 5x divided by the product 2 times the square root of x plus 3. Now, you may be asked to write this as a single fraction rather than two. It just depends on what answer or what your answer choices look like. So if we had to do that, we would just need to find common denominators. I would need to multiply this term right here by 2 times the square root of x plus 3 over 2 times the square root of x plus 3. Right? I need to have that 2 times the square root of x plus 3 as my denominator, which means I also have to multiply the numerator by that. If I do that, I'm going to skip some steps here. I get f prime of x is equal to 10. So I get 10 times the quantity x plus 3 plus 5x all over 2 times the square root of x plus 3, which is equal to, which is equal to 15x plus 30 divided by the product 2 times the square root of x plus 3. Again, you can double check my math with the simplifying there, but that should be the answer you eventually end up with. Okay, so again, the problems are getting tougher, they're getting longer, but they're just using the rules that we've learned. So there's more steps, but as long as we stay organized, as long as we understand each step and make sure we are doing things that are mathematically sound, we should be okay. All right, on to number 8. I'm going to erase this. Number 8 has a little trig function for us. So this one also requires two rules. The difference is we have a quotient rather than a product. So we have a chain rule because we have an inside function and an outside function. So our inside function is going to be what's inside of our sine function. So inside, and we'll just call this c, is going to be our 2x plus 1 all over the quantity x minus 3. Our outside function is going to be that sine function. So I get sine of c. So this time I'm going to start with my chain rule because that's the first rule I need to apply. And that means I need to take the derivative of my outside function. Well, the derivative of my outside function is the derivative of sine of c, which ends up being cosine of c. But again, we know that c is equal to the quantity 2x plus 1 divided by the quantity x minus 3. So you could just leave it as c and then at the end substitute in. I'm just going to substitute in immediately. I now need to multiply by the derivative of my inside function, and this is where the quotient rule comes in. So if I come over here, the derivative of c prime, or the derivative of my inside function, is going to be derivative of my numerator, so 2 times my denominator, minus my numerator, times the derivative of my denominator, which is just 1. And then that is all over my denominator squared. Okay, I can do some simplifying. So that's going to get me 2x minus 6 minus 2x minus 1. Don't forget to distribute that negative. And then my c prime, or the derivative of my inside function, is going to be equal to negative 7 all over the quantity x minus 3 squared. Oops. Just needed a square. Okay. So this is going to come up and be the derivative of my inside function. And the rest of this is just simplifying. So again, if you're not sure what we did up to this point, I would encourage you to stop the video and replay this, think through this, because when we keep going, again, all we're doing is simplifying, and there's not much to simplify here. We could actually just leave it how it is, or we could rewrite it as one fraction, which is what I'm going to do. So g prime of x, I'm just going to multiply my two numerators together. And my denominator is going to be the quantity x minus 3 squared. Don't have to find any common denominators because we're not adding or subtracting, we're just multiplying. Okay, again, main thing to take away from this problem is what two rules do I need to use, and in what order do I need to apply them, right? Do I need to do the quotient rule first? Do I need to do the chain rule first? Make sure you're keeping all of your variables and functions straight. Last problem for this video is going to be number 10. So a bit of a different problem. We're given a graph this time, but we still may need to apply the chain rule. It says, given the graph of h of x to the right, find the equation of the tangent line to the graph of p of x, which is equal to the square root of h of x. And we're finding the equation of the tangent line when x is equal to -4. Well, you know what I like to do when I write a tangent line equation? I like to start off with my general formula for a tangent line and then fill in what I need to. So I know what my x1 is, right? That's going to be -4. And I should be able to figure out what my y1 is. So my tangent line, it's to the graph of p of x. So let's find out what p of -4 is. Well, that's going to be equal to the square root of h of -4, which is equal to h of -4 is equal to 4. So that's equal to 2. So here's my y1. So I have my x1, I have my y1. We can fill those in. And I just need my slope, or my derivative of x plus 4 inside. And the derivative is the toughest part of this problem. We have to find the derivative of p of x. So p prime of x, actually let's rewrite p of x first. So whenever you see a radical, again, I like to just rewrite it using an exponent because then we can use the power rule. So I get h of x to the power of 1/2, because that's what square root means. So this is one of the easier chain rules. Again, I'm not going to go through all the steps. I'm just going to say it out loud. And then if you're having trouble, again, I would encourage you to go back to that first video where we went through some very detailed examples of how to apply the chain rule. But if I need to find p prime, I'm going to take the derivative of the outside. So we get 1/2. Oops, let's pull that down. 1/2 times h of x to the power of -1/2 times the derivative of the inside. And in this case, h of x is our inside function. So times h prime of x. Now, I need to find the derivative when x is equal to -4. So let's just do some substitution and see if we can evaluate here. So p prime of -4 gives me 1/2. H of -4 we already know is equal to 4. H prime of -4. Well, if we come up here, we notice that the graph is linear. So the derivative, or the slope of the tangent line at x equals -4, is just equal to the slope of that line, right? Because the graph is linear. So if we look at the slope, we end up having a slope of -1/2. So we get times -1/2. And if we evaluate negative 1/2 times 1/2 is negative 1/4 times, just make sure we know that this was a negative 1/2 to the power. So we get times 1 over the square root of 4, which is equal to negative 1/4 times 1/2, which is equal to negative 1/8. That is the value of p prime of negative 4. All right, there are some more problems to work through in this packet for you to continue practicing the chain rule. Again, this is something you're going to continue to hone. The only way you get better at applying these derivative rules is to practice, practice, practice. Think about what you did wrong, and then try to fix it the next problem. Okay, this is Mr. Fawcett. As always, enjoy the rest of your day, and I look forward to seeing you for our next lesson.